Imagine you woke up tomorrow and Earth was gone. Not destroyed, not damaged, just gone. Replaced by empty space, a faint memory, and one very uncomfortable question. How much would it cost to build another one? It sounds like a joke, but scientists, economists, and astrophysicists have actually tried to answer it, and the numbers they came up with will make your brain do something strange. First, they'll seem absurdly large, then they'll start to seem too small. Let's find out why. First, what are we actually buying? Before we price anything, we need to decide what we're pricing. Earth isn't just a rock, it's a rock with a very specific set of impossible features. It sits at exactly the right distance from exactly the right kind of star. Not too hot, not too cold. It has liquid water, the only planet in our solar system that does. It has a magnetic field that wraps around it like an invisible shield, blocking the radiation that would otherwise strip away our atmosphere and cook everything alive. It has plate tectonics, which recycle nutrients through the crust and regulate the climate over millions of years. And it has 4.5 billion years of biological trial and error baked into every cubic inch of soil. You can't just order that on a website. So let's break the cost into layers, like peeling an onion, except each layer costs more than the entire global economy. Layer 1, the raw materials. Start with the basics: iron, nickel, oxygen, silicon, magnesium, the stuff Earth is actually made of. An astrophysicist named Greg Laughlin once tried to calculate Earth's value as a raw physical object. He built a formula based on mass, temperature, age, and the one feature that separates Earth from every other planet we know of: the ability to support life. His answer? $5 quadrillion. That's a 5, followed by 15 zeros. For comparison, the global real estate market, every home, every office, every farm on Earth, is worth around $217 trillion. Laughlin's number for just the planet itself is roughly 23 times that. But here's the thing. He also ran the same formula on our neighbors. Mars came in at around $16,000, less than a used car. Venus came in at 1 cent because its atmosphere is almost entirely carbon dioxide with winds pushing 224 miles per hour. 1 cent. The difference between Earth and Venus isn't size. It isn't distance from the sun. It's that razor-thin set of conditions that makes life possible. That's what you're actually paying for. Layer 2. The living systems. Now here's where it gets strange. Raw materials are just the hardware. Earth also runs software, an invisible operating system of biological processes that keep everything alive. Scientists call these ecosystem services. They're the things nature does for free every single day that we've never had to pay for. Bees pollinate our crops. Forests filter our water. Wetlands absorb floods. Oceans regulate our temperature. Bacteria in the soil break down waste and create the nutrients that grow our food. A group of ecologists and economists once tried to calculate what it would cost to replace these services if we had to build them artificially. Their estimate? $33 trillion. Every year, not once, every single year. By 2011, an updated study put that number at $125 trillion annually, roughly twice the world's GDP. Think about that. Nature quietly performs more economic work each year than every government, every company, every factory, and every human being on Earth combined. And we've been getting it for free. Layer 3, the atmosphere. You breathe it without thinking. 78% nitrogen, 21% oxygen, trace amounts of everything else. Getting that mix right took roughly 2.4 billion years of photosynthetic life, slowly pumping oxygen into the air. There is no machine that does this. There is no factory we could build that would replicate 2.4 billion years of biological chemistry on a deadline. Just warming Mars to Earth-like temperatures would require roughly 10 to the power of 24 joules of energy, equivalent to humanity's total energy consumption for 10,000 years. And that's just the temperature. That's before the oxygen, before the water cycle, before the soil microbes, before the magnetic field. The math doesn't break down here. It just quietly gives up. Layer 4. Time. This is the cost nobody talks about. Everything above assumes you could build a replacement Earth quickly, but you can't buy time. The fertile soil beneath a cornfield took 500 years to form. The coal we burn in an hour took 300 million years to compress. The ocean's chemical balance took hundreds of millions of years to stabilize. The biodiversity in a single handful of rainforest soil represents billions of years of evolution that cannot be recreated, reconstructed, or reverse engineered. You could spend every dollar that has ever existed, and you still couldn't buy back a single extinct species. So what's the total? Here's the honest answer. As one Stanford economist put it, ecosystem services are so essential to human life that there is no price we could pay that would be enough to replace them. The economic models collapse. The calculators run out of digits, because at some point, you're not pricing a planet. You're pricing the only place in the known universe where value itself exists. Without Earth, there are no humans. Without humans, there is no economy. Without an economy, the concept of cost means nothing. Earth isn't an asset inside the economy. Earth is the economy. Then why does any of this matter? Because every year, we quietly subtract from that number. Scientists estimate we're losing between $4 trillion and $20 trillion worth of ecosystem services every single year through deforestation, soil degradation, ocean acidification, and species extinction. Not losing it to a disaster, losing it to Tuesday, to ordinary decisions made by ordinary people who never had to see the invoice. Laughlin, the astrophysicist who priced Earth at $5 quadrillion, said he never intended the number to be practical. He just wanted people to pause, to hold that number in their head for one moment and ask a simple question. If we wouldn't sell it for $5 quadrillion, why are we giving pieces of it away for free? We live on the only known object in the universe that can support a human life. The only place with breathable air, liquid water, and soil that grows food. The only address in billions of light years that has ever produced music, mathematics, or a feeling of being home. We don't know what it costs the universe to make it, but we know we can't make another one, and we know exactly what it costs to lose it. Nothing up front, everything later.